Determine the values of b and c such that the function g of x equals b over x squared for x is less than -1 and cx squared minus 2x plus 5 for x is greater than or equal to -1 at the x-coordinate x equals -1 will be continuous and differentiable. For continuity, we need the limit as x approaches the x-coordinate of -1 from both sides of the function g of x has to equal g of -1. G of x here is a split expression function, and it does split right at the x-coordinate of -1, so the two-sided limit will have to be evaluated from each side separately. So we'll have the left side limit of g of x and the right side limit of g of x for the x-coordinate of -1. Let's start with the left side limit of -1, and that means we are less than -1, and we will use this for our expression of g of x. So we have limit as x approaches to -1 from the left side of b over x squared. We can now plug in -1 in for each of the x's, and that'll give us b over -1 squared, which is b over +1, which is just b. The right-sided limit indicates that we are now greater than -1, so we will use this expression for g of x, cx squared minus 2x plus 5. We can now plug a -1 in for each of the x's. That'll give us c times -1 squared minus 2 times a -1 plus 5. -1 squared is a +1 times a c is a c. A minus 2 times a -1 is a +2. And then plus 5, which will give us c plus 7. We also need to look at g evaluated right at -1, and that's going to be determined by the one that includes -1, which is that one for the expression. And we will plug a -1 in for each of the x's, c times -1 squared minus 2 times the -1 plus 5. -1 squared is a 1 times a c, -2 times a -1 is a 2, plus the 5, which will give us c plus 7, just like the right-sided limit of -1 did. We have to have all three of these match for continuity, so we know that b does have to equal c plus 7. That equation has two unknowns in it, so we will need to get more information to solve this, but we also want this function g of x to be differentiable. And differentiable means continuous on the derivative, so we will find the derivative of g of x here, g prime of x. To work out the derivative, the first expression for g of x, we may want to rewrite that. That is bx to the -2. So we can work out the power rule. The power rule says bring down the power -2b, and then subtract 1 from the power, so it'll be -2b x to the -3. Now the x to the -3 can move down to the denominator, so we can just write it as -2b over x cubed. And this holds true for x is less than -1. The derivative of the second expression will be bring down the power for the first term to multiply it with the c, subtract 1 from the power, and then the -2x becomes a -2, the 5 becomes a 0. And this will be true for x is greater than -1. You can't immediately say it includes -1 because that depends on it being differentiable. But we want to force this to be differentiable, so we will want that to be included, and we're going to find the b and c that make this true. We need this function, g prime of x, to be continuous at -1. That's what it means to be differentiable, the continuity of the derivative. So it'll be the two-sided limit as x approaches -1 for both sides of g prime of x equals g prime of -1. Since the g prime of x is a split expression function splitting at -1, we do have to work out the limit from each side separately. So we have the left side of g prime of x and the right side of g prime of x. For the left side, we have a situation where we are less than negative 1. We will use this for g prime of x, negative 2b over x cubed. We can now plug in negative 1 in for each of the x's. That'll be negative 2b over negative 1 cubed, or negative 2b over negative 1 cubed. Negative 1 times negative 1 is a positive 1, times 1 more negative 1 is negative 1. And negative 2 over negative 1 is positive 2, so that comes out to 2b. For the right-sided limit, that's the situation where we are greater than negative 1, so we will use this expression for our g prime of x, 2cx minus 2. We can now plug in negative 1 in for each of the x's. That'll give us 2c times negative 1 minus 2. 2 times negative 1 is negative 2, so we have negative 2c and then minus 2. And last of all, we want to evaluate g prime right at negative 1. So we look at the expression that includes negative 1, and that'll be this one. We plug negative 1 in for each of the x's. It'll be 2c times negative 1 minus 2, which is negative 2c minus 2. That one will match the right side limit already. But we needed to match the left side limit as well. All three of those have to match. And that gives us the result that 2b is going to have to equal to negative 2c minus 2. And we now have two equations with b and c in them. We have to simultaneously solve these. The easiest thing to do is to take the first one, result for b, and plug it in down here for b. So that will give us 2 times c plus 7 equals negative 2c minus 2. 2c plus 14 equals minus 2c minus 2 after distributing the 2 on the left side. Add 2c to both sides, so we have 4c. And subtract 14 from both sides equals to negative 16. Now divide both sides by 4, and c comes out to a negative 4. Now that we have the c figured out, we can take this result of c and plug it back in up here to find b. b will be negative 4 plus 7. Negative 4 plus 7 comes out to 3. And there's your b and c values.